All right, we got chapter 6, day 1, random variables, probability models, expected values, and standard deviations. This is not difficult at all. It's just tedious, but it's definitely not difficult. So let's see what we can do, okay? All right, put the mouse here and slide this up. All right, so go ahead and write down random variables. What they are is listing all the possible outcomes and a probability model that identifies the probability of each outcome. And again, you're going to want to stop the video a lot so you can write all this down. I can kind of fly through it because you have the pause feature. All right, this is a simple probability model, okay, for a single die. That's really, really easy to understand. The probability of all of them is 1/6. Notice that the probabilities all add up to 1 if you add them all up. It won't go over 1, and there's no negative probabilities. That's another powerful feature that you have to learn. Okay, so the next one is the sum of 2 dice. And the sum of 2 dice will range from 2 to 12, obviously. I won't do all of them, but let's look at the 7, which is the most common roll. That could be a 6, a 1 and a 6, a 2 and a 5, a 5 and a 2, a 3 and a 4, or a 4 and a 3. Okay, those are all the possibilities on that. Okay, so that's pretty easy to understand. And that's 6 total rolls, okay? That's 6 total rolls, 6 out of 36. As you get away from the 7, there are fewer possibilities. The 12, only a 6, 6 is the only roll. Of course, a 2, only a 1 and a 1, okay? So go ahead and pause the video and write those down for that. And if you were to add up all of these probabilities, yes, you will get 1. It'll be 36 out of 36. Okay, so now the next one, 1A here. There are only 4 problems you're unsure about on the practice test. The rest are guaranteed. The probability that you will miss all 4 is 0.15, miss 3 is 0.18, miss 2 is 0.21, and miss 1 is 0.35. Create a model for the number of mistakes. No problem. I'm sure you can just go ahead and read that prompt and be able to put that here. Remember, X is the event itself, and P of X is the probability of that happening. And again, that's a very, very easy model to understand. Now, the next one, again, pause the video on that to understand that if you need to, okay? The next one is, let's see here. There we go. Just let this all the way up a little bit. 1B there. Okay, the next one is you roll a die. If it comes up a 1, you win $10. If you get an even number, you win $1. Otherwise, you win nada. Create a probability model for the amount you win. All right, so you roll a die, and there's 6 rolls of a die. And if you roll a 1, and a 1 comes up 1/6 of the time, I'll circle that here, you're going to win $10. And that's just the decimal equivalent of it there. You don't have to write both of them down. I just did, okay, for you to understand. If you roll an even number, which is 2, 4, or 6, that's obviously 3 of those. You win $1. And otherwise, there's 2 rolls left. So a 1/3 chance or 2/6 chance of winning nothing. Okay? All right. Okay, now we're going to go to C. Okay? All right. So for C, let's slide this up a little bit more. A coin will be flipped until a head shows, but we will stop after the 4th flip, even if that doesn't happen. Create a probability model for how many times you flip the coin. No problem. Okay, you're gonna flip a coin until the head shows. Well, there is no 0 here, so keep that in mind, that there is no 0. Doesn't exist, because the first is a 1, right? The first flip. There's a 50% chance that happens. All right, there's a 25% chance that the first head is on the second flip, because that's a half times a half. Okay, half times a half is 1/4 of 25%. There is a 1/8 chance, or 0.125, that the first head happens on the third flip. That is a half times a half times a half, which is 1/8. Okay, and then etc. Okay, and then you're going to stop after the fourth flip, even if it doesn't happen. Fine. Okay, that's pretty easy. 1D. Okay, this is combinations. Okay, a box contains 12 light bulbs, 4 of which are defective. You choose 3 bulbs at random. Create a probability model for the number of good bulbs you get. All right. So you got 8 good bulbs and 4 bad. Okay. So the probability, I need to write this, so this 12 choose 3 down here. Every one of these is divided by 12 choose 3. Divided by 12 choose 3. Because there's 12 light bulbs and you're going to choose 3 of them. 12 light bulbs and you're going to choose 3. So that's the denominator every time. So for the first one, 0, that means if you, for how many good bulbs you get? 8 bulbs, I chose 0 of them, times 4 of the bad ones, but I got 3 of them. The next one, 8 bulbs, I chose 1 of them that were good, and 4 bulbs that were bad, I chose 2 of them. And by the way, it's divided by 12 choose 3, because there's a total of 12 light bulbs and you're choosing 3 of them. Now, you don't really have to worry about crunching those numbers. I would just write this down. If you can pause the video and just write this down, okay? We're just working on making probability models. That's all we're doing. Okay? We're not doing anything super fancy. So, all right, so step 1 is you need to be able to make these models. And by the way, these are called discrete random variables because they're a countable number of outcomes, okay? What can happen is countable. That's called discrete. That's a very unusual name because discrete usually means be quiet or be secretive, but in math, it means totally something different. It means a countable number of outcomes, okay? All right, let's go on to the next one. Let's go on to number 2 here. Compute the statistics of a random variable. Whoops. What happened? Okay, there we go. Okay. Compute the statistics of a random variable. Okay. Now, how do we find the expected value or the mean? Okay. The expected value is called the average or the mean. How many would you expect? A simple analogy of this would be, if you have 3 children, how many boys are you expecting? And the answer is 1.5. We know you're never going to have 1.5 boys out of 3. But it is the expected value, okay? If you flipped a coin 10 times, you're expecting 5 heads. It doesn't mean you'll always get 5 heads. It'll vary, but it's the expected or the average, okay? So it has a formula for it. It's pretty easy. You can write this down. Again, pause the video. X sub I means every individual X. Remember the X's? Every individual X. And then times the probability of X sub I times each individual probability. And this means you add them up. And of course, I have it in words. Sum of each outcome times its probability. Okay? Now the variance, remember, variance is the standard deviation squared. We really don't use variance very much in this class, but we use standard deviation a lot. So whenever you see variance, square root it, and you'll get the standard deviation. Let's remember what the standard deviation means. It's the typical distance from the mean, okay? Or the average distance from the mean, okay? So we're going to be using these tables that we developed, and we're going to find the average of the tables, called the expected value, and we're going to find the standard deviation of the tables as well, okay? And we have a general meaning of what that means from our past. Okay, so for the mean for 2A and 2B, let me slide this up so you guys can see it pretty good. And the work will be done for you, and I'll just kind of talk you through it, okay? So let me go ahead and, we're on 2A, so let me draw this out so you can see what to focus on. There's a lot there. Okay, so on 2A, if we find the mean, remember that's called mu, okay? I'm going to take each individual probability and multiply it by x. So I'm going to multiply these two numbers together and then add them up. And you see that here in red. So the average of this table in 1A is 1.7. Okay? Now the standard deviation is a royal pain. Okay? What you have to do is you have to take each individual observation, the 1, the 2, and the 3, and you got to subtract the mean of 1.7, okay? So here we go. And then you got to multiply it by its standard deviation after you square it. So check it out. Here's the first one, 1 minus 1.7 squared. So the first observation, minus 1.7 squared times the probability of it happening, plus, and then I'm going to go 2 minus 1.7 squared times the probability of it happening. And then 3 times minus 1.7 squared, multiplied by the probability of it happening. And all of that you square root. It's very, very time consuming to do. But it's a pretty easy pattern to follow. Okay? So that's 2A. Then in 2B, and I'm going to go ahead and square this, you can see it. Look how long this one is. If you had this situation right here, okay, where you had a 0, a 5, a 10, and a 20, fine. Okay, to get the mean, I'm going to go 0 times 0.2 plus 5 times 0.4. I wrote it the other way, but fine. Plus 0.3 times 10 plus 0.1 times 20, and that comes out 7. That's the mean. We need the mean to get the standard deviation. And again, the standard deviation is the typical distance from the mean. So what we do is we take the distance from the mean on every single entry, the 0, the 5, the 10, and the 20. And we subtract the mean every time, 7, and we square it. And then we multiply it by how often it happens from the table, okay? And once you get all of that, you square root it, and then there's your answer. So this has a mean of 7 and a standard deviation of like 5.5, which is fairly big from that data set. Mostly because these numbers are so far apart in the data set, okay? Another way of looking at this is if you wanted to do this on your calculator, it's pretty cool. You could try this. I'm not going to do it for you, but you can try it. What you have in this data set is you have 2 zeros. You see the 2 zeros? 20% of the data set is 0, 2 zeros. You have 4 5s. 1, 2, 3, 4. Then you have 3 10s. 1, 2, 3, and you have 1 20. If you were to take those numbers right there and put them in L1 like we did in a previous chapter and get the standard deviation, it'll come out the one that's standard deviation of x. It will be 5.56. This is the same thing. All it does is take each individual number and it asks you what percentage of this is it of the data set. The first one's 20%, 40%, 30%, 10%. So that's a good little trick. you might want to take those numbers right there and check, throw those in L1 and see that it's sigma on your calculator. It's pretty cool in the one variable stats. Okay. All right. So I'm going to clear that. All right. The next thing is I wanted you to do C, D. I wanted you to do the other ones. What I'm going to do right here is I'm going to invite you. Oops. Stop. Okay. I'm going to invite you on your own to go through the tables above that we did, okay? The tables above, okay? And pause the video. I'm going to give you plenty of pause and just walk through the examples above and make sure that it's the same answer as what I have here, because you should have been able to figure that out off of the two examples that I did, okay? So go ahead and pause and walk through that at this time. And then I'm going to do the word problems down below to finish up the video, okay? All right. Okay, so let me do G and okay, let me do G. There we go. I'll do G and H. All right, so let's give it a shot here. Last couple in this chapter, this lesson. You draw from a deck of alphabet cards. If you draw a vowel, you're going to win $5. Okay. How many vowels are there? A, E, I, O, U, A, E, I, O, U, 5. I don't know if we're going to count Y or not. But okay, you win $5. Okay. So if you draw one of these letters, there's 1, 2, 3, 4, 5, 6 of those, 6 out of 26, you win $2. Apparently 626 is right there. And the vowels A, E, I, O, U, I'm only counting 5 of them, not counting the Y. 526 is 0.1923. And otherwise you pay $1. So what I did to get this number is basically I went 1 minus 0.2308 plus 0.1923. Basically, it's what it ended up doing. And then you're going to get this right there. Okay? So that's pretty simple. That's how I got that. Now, to get, I want the mean and the standard deviation of this, okay? This is pretty cool. So the mean of this, now keep in mind there's a negative number here because you lost $1. So when you do the mean of this, you're going to take every individual probability and multiply it by X, and you're going to end up with 0.8462. This is often called payout because we're dealing with money. And so just so you know what that means is for every, you might want to write this down. I'd slip it on your notes. For every dollar spent on the game, for every dollar spent, you will return basically, I'll put 85 cents. Sound good? 85 cents. So you're losing about 15 cents every time you play on average. That's what that means. Just so you know, it's kind of a cool way to, let's call it payout. And look at the standard deviation. This is a royal pain. But there it is, okay? And again, pause the video and check that out. Remember, it's every single number in the data set. There's 3 of them. Minus the mean, which was 0.8462, squared. And then you're going to multiply it by how often it happens. A lot of decimals there, very, very difficult. So the standard deviation is about $2.30. That's a huge standard deviation, okay? So again, this is money. So this is about $2.30 of the standard deviation. So this thing may average paying out about 85 cents on the dollar, but it deviates by $2.30. And it's all skewed to the right because you can't go to the left money-wise because you'll run out. It's kind of a cool problem. All right. Now, next one is the last one here of the day. is you have 75% probability of getting into University A. Otherwise, you're going to go to B. All right, so we got to do a little work here. Okay, I could even do a tree diagram if I wanted to. If you get into A, you got a 20% chance of getting 30 grand. Oh boy, I'm going to go tree diagram on this. This is driving me nuts. Okay, so the 75% chance of getting into University A and a 25% chance of getting into B. Okay, so just to make my life a little bit easier here, I'm going to draw this thing out. Find some room on your notes to get that drawn. Okay. So 75% chance of getting into A, and then it says if you get into A, you got a 20% chance of getting a $30,000 scholarship. So this is 20% here, and this will be 80% then if you get into A. Okay. So 0.75 times 0.2 is 0.15. Okay, so there's a 15% chance that you're going to get 30 grand off of 60 grand. So that means you're going to pay a total of $30,000. Okay, and that looks like that one is illustrated right there. Okay, I put them in order of cost. All right, so there's a 0.75 times 0.8 is 0.60. There's a 60% chance that you're going to have to pay the whole stinking thing of 60 grand. Don't go there. Okay, and again, that's illustrated right there in order of cost. Okay, and the last two here we got. I'll change colors for you. Go green. See here, and for school B, you got a 50% chance of getting $30,000 scholarship. So 50%, that's 0.125 on each one, okay? And so there's getting $30,000 off of 40 would mean you're only paying 10 grand, and then this one goes to that one. So I put them in order of the money that would cost, okay? So that's the tree diagram just to get you to the table, okay? So pause the video if you need to, and again, I should write this down. This is for 10 grand, and this is for 40 grand, right? I'm sure I'm doing overkill here. Okay, so I'm going to erase that. Okay, now, we got the table. Here's the mean, okay? Here's the mean. You're going to multiply it all the way through, and the expected cost, or the average cost, would be about $46,750. Okay? Now, the standard deviation is absolutely awful. And I was cheap, and I actually didn't do the whole thing. So I have the start of it anyways. I got the start of this thing. Okay? But you're going to take every individual number, and you're going to subtract 46,750, and you're going to square it, and you're going to multiply it by its individual probability. I didn't quite fit it all on there, but I think you get the idea. And at this point, maybe you just write the answer down because you know how to do this. You've done the same thing 7 times. Okay? So that is Chapter 6, Day 1 of Stat Nation. We'll talk to you.